So next up, we have our final project from the Full Stack Academy campus. It's a project that's very close to my heart. I had a blast playing this. You might have heard a lot of noise coming from our campus last Wednesday afternoon. It may well have been me and a few other people screaming and shouting at our robots. It's just a real technical accomplishment, the following project. So I'm proud to introduce you to JellyRobots.
Hi everyone, I'm Tina, and this is Sam, Denise, and Jonah, and together we are the team behind JellyRobots. We really wanted to build something that was both fun and educational for our users, but also technically challenging for ourselves. So JellyRobots is a 3D multiplayer browser-based game where players can code their own robots with the help of an API that we've written and provided for them. After players spend some time coding their robot with their knowledge of JavaScript and our docs, they can either battle in multiplayer mode or in our training mode. So as you can see in this battle above, one robot has been programmed to run away in a random pattern, while the other robot has been programmed to follow his opponent and rapid fire, which just shoots random projectiles in directions. So our API is meant to be very accessible to beginners. However, advanced players can code robots with more complex behaviors, as you can see over here, and which makes our game fun for those of all skill levels. And now I'm going to pass it over to Sam, who is going to tell you more about our overall architecture.
Thank you, Tina. So now I'm just going to step you through a really high-level overview of what happens when our users program a robot and then submit their code. So when they're programming their robot, that's actually in a code editor that is a React component. And then when they press submit, that component state gets sent up to our server through a Socket.io event, which we see here. So then our server receives that Socket.io event, and that data gets sent into our game loop, which is just a big function that gets called 30 times a second by a set timeout. Then that code gets evaluated and used to update our game state, which is stored on our server Redux store. We actually use a sandcastle to check for any malicious input, and Jonah will tell you about that later. Then we send the game state back to the client, and they update their local client Redux store, and that data gets sent into the animation loop, which is something that Three.js provides for us. And this gets called 30 times per second to re-render the 3D world. And after all of this, our user finally gets to see their robot, all their projectiles, and all the opposing robots on their screen, and it's updated real time. And now Denise will tell us about Three.js, the graphics tool we used.
Thank you, Sam. For our 3D world, we chose to use Three.js. It's a JavaScript library built on top of WebGL. Our game works with an animate loop on our client side that renders all the meshes and objects. We had a few challenges though with Three.js, as it's a heavy loaded library that requires a fast CPU to render all the graphics. We had to perform some performance optimization so our game will run without lags, especially when the scene fills up with robots and projectiles. What we did, it was something simple. We used two different approaches. One approach was using a simple modular math to drop a few frames, because it's better to have skipped a few frames than an accumulated backlog. The other approach we follow was removing all the meshes and objects not needed in the scene, as Three.js does not provide a garbage collection. Now I will pass it to Jonah to talk about more sandboxing.
Thank you. So one of the parts of this project that we really think is the coolest is that in addition to our API, users can input any code that they want. But this really presents two large problems. The first of which is preventing cheating, and the second of which is preventing malicious or erroneous code from crashing our servers. We prevent cheating by implementing our own throttling process, which reduces how often critical functions such as walk and fire can be invoked. In terms of preventing erroneous or malicious code, we used an NPM module known as Sandcastle. Sandcastle provides a sandbox or safe testing environment in which code can be safely executed if it's potentially untrustworthy. Without Sandbox, users could enter whatever they want, included the dreaded command drop table, to devastating results. Our initial approach using Sandcastle was to run the code through Sandcastle once, and if deemed okay, just use eval and evaluate it as normal. However, non-deterministic, impure functions such as the one above that only error out sometimes would not be caught. That would cause big problems in our game loop. As a result, we wrote our own Sandcastle script, which is executed every single time through the game loop and catches errors safely. As a result, users have unlimited freedom as to which code that they write, and they can use unlimited creativity in a safe, secure, and fair game. We encourage you to check it out, test your JavaScript, and play your friends. Thank you.
What do you think, David? Should we use this for the first day instead of StackPretty?
Yeah, I like projects like this where it's like it's hard to make a game where coding and live stuff is fun, but this seems to have a nice mix of those things. I'm not sure about letting people run arbitrary JavaScript code on your server. I think that could be worrisome, but the Sandcastle thing looks really cool.
Can't arbitrary servers run JavaScript code on your browser?
Yeah, but we trust large companies, right? No, just kidding. No, that's true. That's true. We let our clients do whatever, but it's a very good point.
It reminds me of Core Wars.
Yeah,
it's a very old mainframe game where you basically write a little bit of assembly, and your assembly programs fight against other assembly programs for control of the actual resources.
Of memory. Okay.
Wow.
There's various versions of it that are virtualized to different degrees.